Hello. We all know that the Earth is rare, and I was curious about that to see exactly how rare the Earth is, how unique the Earth is, and as far as having life, again, how unique is that? And so I read through a couple of books, one called Rare Earth, Why Complex Life is Uncommon in the Universe by Peter D. Ward and Donald Brownlee, and also Cosmic Jackpot, Why Our Universe is Just Right for Life by Paul Davies. And in Rare Earth, they write, now that numerous stars have been examined, it appears that only about 5 to 6% of examined stars have detectable planets. Perhaps it indicates that planets as a whole are rare as well. Also, to us, the signal is so strong that even at this time, it appears that Earth indeed may be extraordinarily rare. And they write, if some godlike being could be given the opportunity to plan a sequence of events with the express goal of duplicating our, quote, Garden of Eden, that power would face a formidable task. With the best intentions, but limited by natural laws and materials, it is unlikely that Earth could ever be truly replicated. And Cosmic Jackpot, Paul Davies writes, everyone agrees that the universe looks as if it was designed for life. Also, if almost any of the basic features of the universe, from the properties of atoms to the distribution of the galaxies, were different, life would very probably be impossible. And he writes the following on pages 132 to 133. To permit life in at least one place in the universe, 3 very basic requirements must be satisfied. 1. The laws of physics should permit stable complex structures to form. 2. The universe should possess the sort of substances such as carbon that biology uses. And 3. An appropriate setting must exist in which the vital components come together in the appropriate way. Even these 3 requirements impose very stringent restrictions on physics and cosmology, so stringent that they strike some scientists as nothing short of a fix. And later he writes, calculations suggest that even small changes in some key parameters would wreck the familiar structure of the universe and prevent life from arising. And then going through the 2 books, I found a list of things that make the Earth rare, mainly 12 main things that some of these things we know about just in general, but I thought it was interesting to actually compile a list so we don't just brush it off and say, yeah, sure, life on Earth is rare, but it still came through evolution, but to maybe think about things a little more, maybe a little bit more, and think, well, maybe evolution isn't quite the right answer. Maybe that isn't the right answer for how life began, and for where the universe came from, and for life on Earth. And let's see. Let's starting out kind of from the universe in general, and then narrowing it, focusing down to the Earth. First is the right kind of galaxy, the spiral galaxy, which means there are enough heavy elements, not metal deficient, not a small, elliptical, or irregular shaped galaxy, and no planet such as Earth can exist in the outer regions of the galaxy. 2 is the solar system, with stable planetary orbits. 3rd is the sun, with the right mass that's large enough. 2, that it doesn't have too much ultraviolet radiation. 3, that it does not pulse rapidly or change its energy output. 4, that it's high in metal content, causing the writers of Rare Earth to say that it appears we orbit a rare sun. And 5, that the sun is located in a safe region of a spiral galaxy, not in the center, not in a globular cluster, not near an active gamma ray source, not in a multiple star system or even a 2-star system, not near a pulsar or near stars too small, too large, or too soon to go supernova. 4th is the moon, which is the right size and right distance from the Earth. And the authors of Rare Earth say that the likelihood that an Earth-like planet should have such a large moon is small. Also, the moon stabilizes the Earth's tilt, which strongly affects the Earth's climate. The seasons are not too severe. It also provides long-term stability of Earth's surface temperature. Excessive axis tilt could have led to the total freezing over the oceans, a situation that might be very difficult to recover from. Also, the moon causes lunar tides and slows the Earth's rate of rotation. Fifth is the location of the Earth. Its location in the galaxy, not in the center, on edge, or halo. Second, it's just the right distance from the sun, which gives liquid water near the surface, and it's far enough away to avoid tidal lock. Also, the location of the Earth allows for low asteroid-comet impact rate. And this is thanks, we could say, to the size and location of Jupiter, which acts as a comet and asteroid catcher. Also, it may be that Jupiters, like our own, in regular orbits, are rare as well. Says the book from the book Rare Earth. And let's see. It says, to date, all tend to be in orbital positions that would be lethal rather than beneficial to any smaller rocky planets. Sixth is the proper rotation of the Earth, which is unusual to other planets and satellites in our solar system. 7 is the size of the Earth, which is the right planetary mass. That leads to retain an atmosphere and ocean. Atmosphere is just right to maintain adequate temperature, composition, and pressure for plants and animals. And it has the right level of oxygen. There's also, because of the size of the Earth, there's enough heat for plate tectonics, which created the continents. And we must have the continents, or else the planet's ocean may never achieve a chemistry suitable for animal life. And also the size of the continents is just right. If we don't have any continents, the planet would be too hot. And if the continents were too big, then the planet would freeze. Also, let's see, the size of the Earth and the plate tectonics creates biotic diversity, enables a magnetic field which protects us from cosmic radiation, and acts as the Earth's global thermostat. Also, the Earth has a solid molten core, which produces a magnetic field, protects the surface of the planet from radiation from space, and the metal-rich core of our Earth is responsible for much of its hospitality to life. Also, gravity. From Cosmic Jackpot, he writes, if gravity were a bit stronger, all stars would be radiative and planets might not form. If gravity were somewhat weaker, all stars would be convective and supernovas might never happen. Either way, the prospects for life would be diminished. Number 8 is the chemical composition of the Earth. 26 elements, including carbon, oxygen, nitrogen, phosphorus, potassium, sodium, iron, and copper, play a major role in the building blocks of advanced life. We also need hydrogen, sulfur, and liquid water. 9, the ocean. It's neither too big nor too small. From Rare Earth, the oceans contain enough water to cover a spherical Earth to a depth of about 4,000 meters. If the surface of the planet varied only a few kilometers in elevation, Earth would be devoid of land. Thus, the planet's remarkable mixture of land and oceans is a balancing act. 10 is the carbon level on Earth, enough for life, but not too much for a runaway greenhouse effect. And 11 and 12, the last two, come from Cosmic Jackpot. 11 is the importance of neutrons. I should like to read here from page 145. He writes that the fact that the neutron's mass is coincidentally just a little bit more than the combined mass of the proton, electron, and neutrino is what enables free neutrons to decay. If the neutron were even very slightly lighter, it could not decay without an energy input of some sort. If the neutron were lighter still, yet only by a fraction of 1%, it would have less mass than the proton, and the tables would be turned. Isolated protons rather than neutrons would be unstable. Then protons would decay into neutrons and positrons with disastrous consequences for life, because without protons, there could be no atoms and no chemistry. And in regards to dark energy, on page 149, he writes, about 20 years ago, Steven Weinberg pointed out that if the magnitude of dark energy were only moderately larger than the observed value, it would have frustrated the formation of galaxies. Galaxies form by the slow aggregation of matter under the action of attractive gravitation. If this tendency were opposed by a strong enough cosmic repulsion force, galaxies would be unable to grow properly. And as I have already remarked, without galaxies, there would probably be no stars or planets or life. So our existence depends on the dark energies not being too large. A factor of 10 would suffice to preclude life. If space contained 10 times as much dark energy as it actually does, the universe would fly apart too fast for galaxies to form. A factor of 10 may seem like a wide margin, but 1 power of 10 on a scale of 120 is a pretty close call. The cliché that life is balanced on a knife edge is a staggering understatement in this case. No knife in the universe could have an edge that fine. And I'd like to say that if you would like, I'd be happy to email you this complete outline that I have here of the 12 main points of why the Earth is rare. Thank you.